Okay, so now that we have our error bars inputted into our graph, we can discuss some of the patterns and trends that we're seeing. So the first thing I want to look at is overall, what is the data telling me? So here I can see River A has a higher average for dissolved oxygen levels than River B. River B has lower average dissolved oxygen levels. So you want to discuss the overall patterns. Second, you want to look at how large are the error bars. The error bars represent the standard deviation. So we want to make sure that we discuss how much variation there is in our data. Well, large error bars indicate that there's a lot of variation in our data, that the data points are very spread out from the mean, which means that our results may not be very reliable, or maybe there's just a lot of variation in, for example, whatever the test we were doing, genetic variation or things like that. So you wanna look at how big are the error bars. Well, mine is 0.8 or 0.7 out of an average of 9.2 or 6.7, relatively small. So that indicates that the results are reliable and consistent. The next thing I want to look at is, do the error bars overlap? Overlapping error bars means that there is not a significant difference between one group and the next. And that's because the data points could fall within either group. Well, in this case, the top of this error bar, if I were to go along, the top of that error bar does not overlap with the bottom of this error bar. So since there's no overlap in the error bars, we can suggest that the dissolved oxygen concentration in River A is significantly higher than the dissolved oxygen content in River B.